so on to the next. We have, is there more wood in a 40-foot high tree trunk with a radius of 2.1 or a 30-foot high tree trunk with a radius of 2.5? Assume the trees can be regarded as right circular cylinders. All right. Let's see what we got going on. So the main idea here is we are utilizing the volume of a cylinder. So these tree trunks can be regarded as cylinders with a height h and radius r. So recognize the volume of the cylinder. Well, the volume of a cylinder is going to be the area of the base multiplied by h. So the area of the base is pi r squared. That would give you the area of this circular base, pi r squared, and then multiply it by the height, h, to get the volume of a cylinder. So essentially this one, we take the given radius and the given height to compute the volume for both scenarios and then compare the outputs. But this is the equation you'll want to utilize. Pi r squared times h. All right, where am I going next? So problem 5. Yep. The water reservoir for a city is shaped like a rectangular prism, 220 by 70 by 11. At the end of the day, the reservoir is 75% full. How much water must be added overnight to fill the reservoir? Okay, so recognize at the end of the day, the reservoir is 75% full, which means we have to fill it back up. It will take 25% of the overall volume to fill it back up. So we need to find the volume of this rectangular prism and then take 0.25 multiplied by that volume to figure out how much we need to add to fill the reservoir overnight. So we have 220 by 70 by 11. So length, width, height of the rectangular prism. So recognize a rectangular prism is just a nice box, essentially. So we can call this distance 220, we can call this distance 11, and we call this distance 70. So to find the volume, simply take 220 by 11 by 70, which will give you some number. That number is the volume of the entire tank, and then we're told we have to fill up this reservoir, and to fill it up completely we need to add 25% of this volume. So volume is 70 by 11 by 220. 70 by 11 by 220. 169,400, 169,400. So there's my volume. And at the end of the day, the reservoir is 75% full, meaning there's 75% of this left at the end of the day, which means we have to, in order to refill it completely, we have to add 25% of this. So 0.25 multiplied by our volume will tell us how much we need to add to this reservoir to fill it up overnight. All right, let's jump to number 6. All right, so number 6, a nice application of Pythagorean's theorem.
The figure shows a region to be covered with plywood on stairs. The area of the region is 52 square feet. Suppose that the stairs rise at a shallower angle and are 6 feet tall. What is the area of the region to be covered in this case? So I know that. It has to give me area of the 52. Suppose shallower angle is 6 feet tall.
Okay, so let's draw a picture. Alright, so we have a triangle, a right triangle at that, with a base of 13, height of 8, and we're told that the area is 52 square feet. Suppose that the stairs rise at a shallower angle and are 6 feet tall. So this would be case 1. Case 2, it doesn't say anything about changing this 13. It doesn't say anything about changing the length, just the height. So the area of a triangle is 1/2 base times height. So recognize where this is coming from, 1/2 base times height. Well, if you took base times height, that would give you the area of a rectangle, and then half of that would be the area of this triangle.
Suppose the stairs rise at cover in this case is...
I don't even get why they introduced this first case, but okay. So the area in the second case is still governed by 1/2 base times height. Here, the base still 13, the height still, it is now 6. 3 by 13, 39. So this will give me 39.
Alright. So the base I called 13, the height I called 16. Do the multiplication to arrive at 39 feet squared.
Why feet squared? Well, we're measuring an area. That's square feet. We got it. All right. Ooh, a perimeter. Okay. Find the perimeter and area of the triangle. So let's sketch out our triangle. 10, 10, 6, and 16.
The perimeter is blank. So the perimeter
is the distance all the way around. So the perimeter of this triangle is going to be 10 plus 16 plus 10. 10 and 10 give you 20. Add it to 16 to give you 36. So the perimeter is 36. Be sure to include the correct units, 36. Everything is given in inches, so this is inches. Hopefully it appreciates that format, and it does. Yay, we got it. The area is blank. So let's come back to our picture. So recall that the area of a triangle is 1/2 base times the height. So the base we can refer to as 16, The height we can refer to as 6. Okay. 1/2 base, well that's 16. My height, well that's 6. 8 by 6, 48. 48 what? Well, everything is given to us in inches, so this would be inches squared. Area, squares. Alright. So we have 48 inches squared. 48 inches squared. Got it. All right, the perimeter, simple rinse and repeat of what we just did. Find the perimeter of the triangle. And then they will have you go through and find the area, very similar to what we just did. So we'll skip over this one. Number 9, find the perimeter and area of the rectangle. That is 2 meters by 1/2 meter in my case, or 4 meters by 0.4 meters. Again, the perimeter, that's the distance all the way around. So 4 plus 0.4 plus 4 plus 0.4. Do include these other sides in the perimeter, even though they're not labeled. And then they'll go through and have you find the area. Well, that's a simple multiplication of the base times the width. 10, yay, find the perimeter and area of a parallelogram with sides of 7 feet and 10 feet, and a distance between the 10-foot sides of 4 feet. Okay, or in this case, maybe I should stop reading off my paper and read off of what you guys are looking at. Find the perimeter and area of the parallelogram with sides of length 10 and 19 feet. And a distance between the 19-foot sides of 7 feet. So this picture. Recognize the perimeter. Well, that's a very nice application of 19 plus 10 plus 19 more plus 10 more. So 19 and 19, that's 20 by 2 minus 2, so 38. 38 plus 20, so 58. For the perimeter, simply add up the distance all the way around. For the area, 19 feet, 19 feet. Base times height. So I'd have that plus that. So if I'm the area of a parallelogram, so I think I remember the area of a parallelogram. So the area of a parallelogram, I believe, is the base multiplied by the height, where the base is 19 multiplied by the height. The height is 7 in this case, so 133. God, I think that's right. I haven't found the area of a parallelogram. You could cut this up into a triangle section, and a rectangular section, which might be nice, but then recognize you would be pressed to find the distance between here and here. So recognize it's not 19. The 19 distance is from this vertex to this vertex. So let's go ahead and check this answer. And that is how you find the area of a parallelogram. Simply take the height and then multiply it by the length of your base. Find the circumference and area of the following circle. So recall that circumference of a circle is pi times the diameter, and the area of a circle is pi r squared. So in this example, they give us the diameter. So simply shove 55 in for the diameter. Recognize if the diameter is 55, the radius is 55 over 2. So, and then also the circumference. The circumference is measured in a length unit, where a length unit is, in this case, feet. Square feet would be an area, cubic feet would be a volume. Another circumference of a circle. Find the fraction of a circle subtended by the given angle. So this really is saying 60 degrees is what fraction of a circle? So let's look at a picture. So here's a circle, and so this circle has 360 degrees total, which means exactly half of the circle is going to be 180 degrees. Similarly, a quarter of the circle is 90 degrees. And you can keep playing this game of dissecting the circle. So 180 degrees would be 1/2 of a circle. Okay. So how can we cook this up in general? Well, 90 degrees is 1/4 of a circle. So recognize that this fraction over here, the blank of a circle, well, that's really coming from the number of degrees divided by 360 degrees. So 180 degrees divided by 360 degrees gives you a half. So it'd be half of the circle. If you take 90 degrees and you divide it by 360 degrees, you'd get 0.25 or 1/4 of the circle. So in our case, we're going to take 60 degrees and divide it by 360 degrees to see that that is 1/6 of the circle. Type an integer or a simplified fraction. So this would be 1/6 of a circle. Let's go ahead and check the answer. Bada bing, we got it. Same song and dance for this one. 240 degrees. You can think of this as cuts the circle into blank. So simply take 240, divide it by 360 degrees to see what portion of the circle that this 240 degrees gives you. Find the fraction of the circle, so same song and dance here. And find the degree measure of the angle that subtends the following part of a circle. The angle subtends 7/12 of a circle measures blank degrees. Alright, so from where we left off, so recognize degrees divided by 360 gives me the fraction of interest. So what I have going on here would be 7/12 is the fraction of interest. So Some degrees divided by 360 degrees is equal to 7 over 12. We'll recognize we are taking this equation and we're solving for this question mark. So we need to multiply both sides by 360. And let's bring it up here to see that this question mark equals 7 over 12 times 360. 7 over 12. Take the result and multiply by 360 to give us 210. 210. All right. And that completes the geometric modeling homework. So these last three homeworks, there will not be, well, okay, it's going to differ depending upon the classes. So keep your eyes posted in the announcements for the online section to figure out how we're going to handle this. You'll see these last three homeworks on the final exam. So thank you for your attention. I hope you learned something. I hope I don't see you again, which means I hope you passed. So good work. Thank you for your attention, and have a good remainder. Good luck on the final. Yeah. Take it easy.